Okay, when we talk about this graph, we're going to go through here and talk about transforming graphs. And the best way to transform graphs, talk about graph transforming, is to do one. Let's say if we start with this function here, we got y equals x cubed. And we're going to transform this. First, it says under a vertical compression of 1/2. So that means what we're going to do with the vertical compression is going to take this graph and multiply everything by 1/2. And then by a reflection across the x-axis. Now the x-axis is going to change all the coordinates again. So what we're going to do here is the x-axis is going to take all the y and make it negative. So it's going to make it a negative 1/2 x cubed. That's the reflection. Now horizontal translation, 3 units to the right. This is a tougher one here. 3 units to the right means we're going to keep the 1/2 here. To the right means we're going to have x minus 2 cubed. Now why is it x minus 2? Because it's, is it 3 units? Oh, sorry, x minus 3. 3 units to the right. It has to be what makes it 0. Now the last thing it says, then a vertical translation 2 units up. So 2 units up means we're going to add 2 at the end to get the equation. So we're going to move 3 units right, 2 units up, half, factor, and negative in front. Write an equation. What is the equation in the graph of y equals x cubed under a vertical stretch by a factor of 2? So if we're going to do a factor of 2, we're going to have y equals 2x cubed. This is our parent function now. Right here is our parent function. Followed by a horizontal translation of 3 units to the left, okay? 3 units to the left would be 2 times x minus 3, x plus 3 cubed. 3 units to the left. And then a vertical translation of 4 units down. 4 units down minus 4. So we're going to have 3 units to the left, 4 units down. So this is doing all the different things. What are the real zeros of this function? The real zeros of this function is setting this equal to 0. Okay, so we're going to set this equal to 0, and we're going to have 3 times x minus 1 cubed, that's a terrible cubed, plus 6, so we're going to move the 6 over, so we got negative 6 equals 3 times x minus 1 cubed. So divide by 3, so we're going to have a negative 2 equals x minus 1 cubed. Take the cube root of both sides. And now we're going to have a cube root of negative 2. So we're going to have the cube root of a negative 2, and then we're going to have to add the 1, so plus 1 equals x. So my cube root, real zero of this function, is the cube root of a negative 2 plus 1. So as we look at here, it changes up a little bit, but that's okay as it goes through. If we look at how it changes the function and work it out, let's look at what is a quartic function with only 2 real zeros. Well, how do you think we should do this? So what I want to say here is there's many answers to this. So there's not just one answer that will work in this. So what we can do here is say, okay, if it's a 0, 2 real zeros are x minus 5 and x minus 9. Now the other 2 zeros can be imaginary numbers, or these could be squares here if you wanted to, because these could be real zeros being the only 2 that works. If you want imaginary numbers, you can go like anything along the line of x squared plus 1, because that'll give you imaginary numbers. because plus or minus I. So now if we FOIL this out here, we're going to get x squared minus 14x plus 45 times x squared plus 1. And I'll let you FOIL the rest out, and we could FOIL this out again. And that would give me a quartic function. Quartic means it has to have 4 roots. Here's 2, 3, and 4 with 2 zeros and something else. Now why I put this in here again is because these are imaginary roots. Now, like I said, you could do another solution. There's many solutions to this. It doesn't have to be x squared plus 1. It could be x squared plus 2, or anything on that line. It could be a lot of different answers. And another answer could be, you could write it like this if you want to. Squared and x minus 9. Squared and FOIL that out. That would work too. So there's no just one answer to this one. And so like on this one, it says, what is a quartic function with only 2 real zeros? 0 and 6. Well, we could go, what's this say on this one? We're going to go x. What's this k? X and x minus 6. Those are my 2 zeros. And I can say x squared plus 1 again. Those are my imaginary answers. And so when we solve this down, we would have to FOIL it out and get our answer. So we get x squared plus 1. So we're going to have x squared minus 6x and working it out and get our answer. Now, you can FOIL this out a little bit more if you want to. We can say, okay, we're going to get x to the 4th minus 6x cubed plus x squared minus 6x is our function. Now, does the quartic function negative f of x have the same zeros? The same real zeros? Yes. Same zeros? Probably. I wonder if that's a little different. It's just going to put a negative front. It should have the same zeros as it go through the problem. It shouldn't be any different. So yes, they should have the same zeros through the problem. Because if we just put a negative f of x, that means we're just going to put a negative here. That's not going to change that zero. These will stay the same. So that should be no problem at all. Now, the offspring of a parent function like y is a subfamily of all quartic polynomials. This consists of quartics of the form of y equals a times x minus h to the 4th plus k's. Okay, a power function is a function in the form of a times x to the power some power where a and b are non-zero functions. So anything in the power function. If the exponent b is a positive integer, the function is a monomial function. If describes y as a function and x varies directly with or is proportional to the b of the power. The constant a is a constant proportionality. Power functions arise from many world problems. So in other words, we can don't get caught up in the power function. What it means is there's many ways of writing power functions. The 6th power squared, 1/4 power, 2/3 power. There's a lot of different ways to write power functions out. So we're not going to get caught up in writing these power functions out. We're going to spend more time doing these problems in class. And I just kind of wanted to get you a little bit of a start on here. What I would like you to do for homework is, let's start with, on page 343, I want you to do numbers 7 and 13 hand in tomorrow. Thank you.